In software development, we often need to connect objects that generate events with objects that handle them. Many languages use listener interfaces for this. For example, a button class might have a button listener interface with methods like onClick. Sometimes, instead of attaching a listener to an object, we pass it as an argument to a method. For instance, when requesting a HTTP GET, we provide a listener that gets called upon completion. Most modern languages implement event handling as syntactic sugar over existing constructs. In object-oriented languages, event handlers are typically implemented as single-method interfaces, as in Java or in C++ where lambda functions are objects, with a special call method. In functional languages, listeners are implemented as lambda closures that store the handler object references in their lexical scopes. These implementations, however, have notable downsides: excessive memory allocations, leaks if not unsubscribed, manual null checks. Lambda functions store context, requiring heap allocation. Listener interfaces use intermediate objects, also requiring heap allocation. Event handlers are stored as strong references, leading to memory leaks if not manually unsubscribed. Here button lives in form and subscribes in tons of places. When form destroys, button remains because of its subscriptions. Before triggering an event, the application must check if a listener exists, which is often not enforced at compile time and can lead to runtime crashes. Argentum introduces delegates, a special value type mechanism that solves these problems. A delegate is a fat pointer occupying two machine words, requiring no heap allocation. It internally holds a weak reference, preventing memory leaks. Its call operator automatically verifies that the handler exists if it's linked to an object and that the object is still alive and in the correct thread for multithreading. Invocation occurs only if all conditions are met, enhancing safety without complicating syntax. Delegate don't have to be class methods. They can be defined as inline ones, making event-driven code more concise. Argentum supports copying object hierarchies with mutual event subscriptions, ensuring correct crosslinks in the copy, something no other language offers. In this example, our form subscribes to onClick event from its button. When copied, this subscription correctly and automatically preserves in copy. Delegates can be called like regular methods or sent to a message queue for async execution in the main thread. This is useful for delayed execution, handling FFI functions working in system threads, or forwarding callbacks to the main thread without race conditions. Argentum delegates offer a robust, efficient, and integrated event handling mechanism. They eliminate memory leaks, remove the need for manual checks, and streamline asynchronous execution. In Argentum, delegates are a core feature essential for building scalable, multi-threaded applications. But it's the theme for the next chapter.